Hi everyone, very good evening and welcome back to GFG Practice. Welcome back to another problem of the day discussion as well. So, hi everyone, and please give me a +1 in the chat if my voice is clearly audible to everyone. Hi Ecardo as well. So, guys, you can give me a +1 if everything is working fine. And then we'll discuss yesterday's problem of the day, that was count subarrays which have product less than k. So, is my voice clear, guys? Let me just check. We'll discuss yesterday's problem of the day. That was all right. Everything is working fine. Thanks a lot, Rishit, as well. So now let me share my screen and then we can start discussing this particular problem here. Uh, Accardo, for that I am not sure. Maybe it might have been skipped, but I was not the mentor for that problem. So yeah, basically we have to discuss this problem, that is counting subarrays with product less than k. So suppose if we have an array, right? Suppose that we have a particular array. Let's say the array is 1, then we have 2, then we have 3, and then we have 4. This is the array that we are having. So what is a subarray? Subarray is a contiguous part of an array. So maybe I can consider 2, 3, 4 as a subarray, or I can consider 2, 3 as a subarray, right? Contiguous part. Or I can consider 1, 2, 3 as a subarray, or I can consider single elements as a subarray. So basically, I have to take a contiguous part that is known as a subarray. Now, in this particular question, if this is the array that has been given, and suppose the k value has been given as nothing but 7 here, sorry, 10 here. So if the k value has been given as 10, so what I need to find is I need to find all the subarrays which have the product less than k. So I can say that a single single subarray which is having 1, it will have the product less than k. 2 also will have the product as less than k. 3 will have the product as less than k. Then I can say that 1 comma 2 will have the product less than k. I can also say that 1 comma 2 comma 3 will have product less than k. Then I can say that 2 comma 3 will have product less than k, right? Then after that, I think these are all the count: 1 2 3 4 5 6. Yeah, single element 4 will also have the product less than k. So basically you can see here the answer is the count of the subarrays which are having product less than k are nothing but 7. Okay, so there are basically 7 subarrays, you can see. Is this much part clear here, guys? What is the demand of the question? What is the question saying? Is the problem statement clear to everyone? Just let me know in the comments if everyone is clear with this part, and you can confirm that by hitting the like button also. So you can see there are 7 subarrays which are having product less than k. This one, then there is 1 comma 2, then there is 1 comma 2 comma 3, then there is 2, then there is 2 3. Okay, then there is 3 only, then there is 4. So what is the brute force way of doing this, right? The very brute force way of doing this is very understandable. That what I can do is I can, if suppose that I have my I here and I have my j here, so I can consider this as a subarray, this one as a subarray. Then my j is here, so I'll keep a track of the product, and the product till here is also less than k, so I'll consider it. Then my j will come here, and this product is also less than k, right? Because the product will be 6, so I'll consider this as well. So the count will increase. Then after that, when I consider my j here, then this will not be counted, right? 1 2 3 4, the whole product is greater than k. And then after that I can have my I here and j will be here. So initially the product is 2. So basically you can understand one thing very clearly, that what we can do is, and after this you can see that I can move my j forward, so j can move here, right? Then after that I can move my j here. So basically all those subarrays I can consider. So what I can do is I can have a I loop outside and then internal loop j, and then we can do this task. So for that, the brute force method will take order of n square time complexity. Is this part clear to everyone? Please write yes in the chat. Is the brute force approach clear to everybody? Like the very basic thing that we should explain in an interview. This part is clear to everyone, how we can do this particular thing. Okay, if you are clear, then you can hit the like button and give me a +1, and then I will proceed further. Right now, once we have done this, so the issue is how do we optimize this thing? So in this particular case, whenever we have to think about the subarray concept now, so whenever you have to do something with regards to subarray and you have to reduce the time complexity, so in that case you can think about the sliding window concept. Okay, so what you can see is, suppose that we have 1, then we have 2, then we have 3, then we have 4, right? So we have these all these elements present with us. Then what we can do is, if we have the k value as 10, right? So what I can do here is I can consider the windows, right? I can slide my windows as per the requirement. So what I can try to do is, if you will see here now, suppose I will keep a L pointer here at the very starting, and I'll keep a right pointer here at the very starting, and initially I will mark the product value as 1. and then I will multiply this particular element, okay, because my r is always going to move forward and left will only move forward, okay. So what I'm going to do, I am like, suppose that L is here and R is here, and the product is less than this particular thing, less than K. So in that case, I can consider that there will be three subarrays that will exist because of this. So this is what I'm trying to say. If you will observe, so what we will try to do is, whenever we have a window L2R and that product is less than K, then we will count that much length. I'll let you know why we will do this with the help of examples one by one. And whenever the product becomes greater, so suppose my R will reach somewhere here and my product becomes greater, then my L will move, okay. So this is the basic sliding window approach that we'll be using in order to count and solve this particular problem. Whenever there are problems like counting, and there you have to count, so in those kind of problems, the sliding window concept, or you can say two pointer concept, helps a lot. In this, two pointer sliding window is just one step ahead of the two pointer concept, okay. So what we will do is, I'll mark my left here and I'll mark my R here. So now I will take the inside the product, I'll multiply with A of R. So you can see that when I multiply it, so this is 1. So yes, this element is lesser. So how many subarrays I'm having in this range L2R, guys? I thought brute force was order of 2n. No, this way it can be done, right? Yeah, you can see here. Now, in this particular case, L is here, R is here. Now, this product is less than K. Okay. So, since this particular product is lesser than the K value, right? So, in this case, what can we do? So, in this particular case, since the product is less than K, so just give me a minute, guys. Just give me a minute. Yeah, guys, so I hope that I'm back, right? So yeah, what we'll be doing here is, you can see my product is less than the K value, right? So in this particular case, how many subarrays can I count? I'll update the count with count is equal to count plus, right, L minus R plus 1. So let me write it, L minus sorry, R minus L plus 1, and I'll let you know why this will happen. So R minus L plus 1, we can say. So this will be 0 minus 0 plus 1. So basically the count will get updated by 1. Okay, so basically you can understand that here what is going to happen, the count is going to become nothing but 1 here. Then after that, I'll move my R forward. So then what will happen, my R is going to move here, right? When my R moves here, then I will check. So I'll multiply this particular element. So A of R, I'll multiply the rightmost guy. So when I'll multiply to it, so my product is now going to become nothing but 2. So is this product lesser than K? Yes, this particular product is also lesser than K. So in this case, you can see that I am considering which particular window. I am considering this particular window, right? So in this case, L is standing at what? L is standing at 0, R is standing at 1. So the answer will get updated by 1 minus 0 plus 1. So you can see that answer will get updated by 2 because the length of this window is 2. So now you will ask that, okay, how we are increasing it by 2? Because there are two subarrays that you can consider. Firstly, we had already seen one. Now you can see here we will consider 1 comma 2 subarray. So I'll highlight it with a different color. So we will have this subarray that is 1 comma 2, right? And we are also counting this subarray that is 2. So this is how the counting is being done. Is this clear, guys? When you have this 1 comma 2, so basically what you are doing is, you are first of all you are considering this one and then this one. So that is how you will have two subarrays. So that is how this sliding window concept or the pointer concept is helping you here. Now after that, my L is still here because I don't need to move it, and my R will move here, right? Now when my R moves here, so what is the product? So I'll multiply again A of R. So in this case, what will happen here is, now the product is going to become nothing but 6 here. So when the product becomes 6, so again it is in the range, it is less than it is less than K. So now I will consider this particular window. So in this case, I can say that now the elements considered are 1 comma 2 comma 3, this particular subarray. Then the next one is 2 comma 3, right? And the next one is 3. So this is how we are considering this particular subarray. Could you please explain the last part again? Yeah, basically which part, Rishit? Suppose that if you had one like in the current window, suppose if you had 1 comma 2. So just to explain it again, suppose you had 1 comma 2 in this window, right? And this product was what? Then this product was 2, which is lesser than the K value. So in that case, you will say that now L is here, R is here. So L value is 0, R value is 1. So it will be R minus L plus 1. So 1 minus 0 plus 1. So this will be counted as 2. So in this window, we can count two subarrays. How we can count two subarrays? Because one of the subarrays would be 1 comma 2 and another subarray will be 2. So this is how we are counting it, right? Similarly, what will happen when I'll move my R forward? Is it clear, Rishit, or still some clarification is required? Let me know. So after this, what will happen? My R is going to move here, and when my R moves here, then what is going to happen is, then I'll multiply 3 to the product. So when I multiply 3, so the product becomes 6, right? So this I'm considering 1 comma 2 comma 3, this particular window I'm considering. So in that I'll have 1 comma 2 comma 3, then I will have 2 comma 3, and I'll have 3 alone. So 3 subarrays I'll have, right? So that is why you can say that R value here is 2, L value here is 0. So the answer will get updated as 2 minus 0 plus 1. So that will get updated by 3 more, right? And then after this, what is going to happen is, then my R guy moves here and my L is still here. Now when I see the product, so when I multiply it by 4, so it will be 24. Now since the product is greater, okay guys, if you are clear till now, so please hit the like button and let me know, and you can give me a +1 as an acknowledgement as well. Okay, right? So yeah, after this particular part, my product is 24. So in this case, what happens when I have multiplied the A of R? So my product is more. So can I say that now when my product is more, so I cannot consider this window, and my R was only moving one time. So R moves, but now I need to move my L. Correct? Please write L plus plus in the chat for those who are clear with this idea, right? Because now I want to shift my window. Okay, because now I am not able to satisfy in this window is not able to satisfy the condition of product having less than 10. Okay, so in this particular case we need to do L plus plus here. So that is why what I will do is I'll move L here, right? So this will be done kind of inside a loop, because we might have to do it again and again, right? Whenever it happens that the product becomes greater, like it becomes greater equal to K here, so I have to move. Now again I'll consider, now when I'll move my product now, so before moving you can see that this is the Lth element. So since I'm going to move away from it, so I'll divide the product by A of L here, and then after that I'll move. So when I divide it by 1, so when I'll do 24 by 1, so it will be 24 itself, right? And after that I will do a L plus plus. So after the division I'll do a L plus plus, and L will move here. Now still this window is having product as 24, because 2 into 3 into 4 is nothing but 24. Now still this product is greater, right? So I need to repeat this again and again. So that is why I'll be using a while loop. Is that clear? Internally I'll be using a while loop for the movement of L. Whenever the product is greater equal to K, then I will be doing this. Is this part clear, guys? Right. Now again I will before moving forward from this index, I'll divide the product by A of L. So this means that I will do 24 by 2. So that is why the product will become nothing but 12. And then I will say that, okay, since after dividing, I'll move my L here. So that is why what is going to happen here is this product becomes 12, and still it is greater, right? So in this particular case, I'll again, before moving my L forward, I'll divide the product by A of L. So in that case, now this will be 12 by 3, which is going to become nothing but 4 here, right? So now my product becomes only 4. So product will become 4, and I'll do A of L plus plus. So in that case, what will happen? My R is somewhere here, and my L is here, right? This is what happens, and my product is nothing but 4 here. Okay, so in this particular case, my product has become under control. So the while loop will basically terminate whenever this happens. And then I can also say that L should be lesser than N value, right? I should always keep a check. So yeah, in this particular case, what will happen is, now you can observe that since the product has come under control, so I'll consider this particular window, and it will be nothing but L is what? 4 here, R is 4 here. So it will be 4 minus 4 plus 1. So that will come out to be nothing but plus 1 only. So basically only one subarray, which is only 4, will get added. So total, what is the counter after the end of the iteration? So you can see that the counter finally becomes nothing but 1 plus 2 is 3. Okay, 1 subarray, 2 subarrays, then 3 subarrays here, and 1 subarray more. So total number of subarrays is 1 plus 2 plus 3 plus 1. So that is nothing but 7 here. So the count will get updated with this particular value as 7. Okay, is this part clear? And after this, since it became under control, so my R will move forward. And when my R moves forward here, so the moment my R moves forward, so you can see that my R reaches the end of the array. So whenever the R reaches the end of the array, that is when I will end this particular iteration. So is this part clear to everybody? Please let me know, guys. Is this particular part and concept clear to all of you? You can write clear in the chat, and you can acknowledge this fact by hitting a +1 in the chat if you are clear till now. What Subarrays we are considering and all that. You can hit the like button and give me a +1 as an acknowledgement. Okay, Sarjeet is saying yes. What about Rishit? What about Tejas? What about Acardo? And what about others? Right, guys, you can hit the like button as well, Abhinav and other people. All right. So yeah, this was one thing. Now another thing is, what is the time complexity of the approach that I am using? Okay, what is the time complexity? How the pointers are moving? So you will observe one thing. Suppose I had this particular array. So can I say one thing, that my R pointer is like, see, can I say that my R pointer moved throughout the array, right? At one time R was here, then R was here, then R was here, then R was here. So my R pointer moved from the left to right. So because of the R pointer, I'm having order of n time complexity. I can say this. Now somebody might think that I am also running a like I am running a while loop for moving my L. Yes, because I might have to repetitively move my L, but my L is only reaching every index exactly once. So my L is also moving, reach like it is, at the worst case, it is visiting every index exactly once, right? Then this L is always moving forward. With the help of while loop, it just happens that it moves, it just continuously moves, right? So in the worst case, what is happening? L might also reach the end. So in that case, you can say that L is also at only one time. L is doing what? This is not a nested loop. Why? Because L is not always starting from here and ending here, right? Once L has passed a particular index, then it does not repeat. So L is moving from here to here only one time. So that is why you can say that L will also, in the worst case, take how much time? Order of n time for iterating through the array, because it is uniquely iterating. So we can say that the overall time complexity will be order of 2n, and order of 2n is nothing but order of n only, right? So the time complexity of our approach is order of n. Is this part clear to everyone, guys? So the overall time complexity that for the code that we are discussing, it is going to be order of n. Is this part clear to everybody, guys? Just let me know. So the time complexity is going to be nothing but order of n. And if you talk about the space complexity, so still it is order of I think 1 only, because I'm not considering to take any extra space. Now let us start writing the code. You can let me know, guys, in the comments if you're clear, or is there anything that's bothering you, because this problem has been previously asked in Goldman Sachs, right? So it's a very good problem, to be very honest. All right. Now, what we will do here is, here I will initially mark my product value as 1, and then I will say that my left is equal to 0. Okay, so let me mark my L as 0. Okay, and then I can say that I can also mark my right index as 0. And then what I can do is, I can say that while the R is less than n, till that point of time, I will be iterating in the array. And then after that, we will directly do what? We will multiply in the product. So product asterisk is equal to a of r. So we will do, first of all, what? We'll multiply inside the product. We'll multiply the r value. And just after doing this particular thing, what we will check is, we will check that while it happens, right, while the L is less than n, and at the same time it happens that a of and it happens that the product is greater than equal to k. I can write this as L is less than R. That would be better, because they should not cross each other. Okay, are you getting? They should, L and R should never cross each other, no? Because L is the left pointer and R is the right pointer. So L can be less than equal to R, you can say, right? This is one point. Is this idea clear to everybody or not? L should be less than equal to R only. And if this is so, then I will say that, okay, product divide is equal to A of L. So basically, I'll first of all divide this Lth element, and then I will move my L forward here. That is what I'm going to do. And after this particular part is done, then in this particular situation, what we will do is, we will say that now the counter is going to be nothing but counter plus is equal to nothing but R minus L plus 1. So I can say R minus L plus 1. That is going to be the update here. And initially I can mark my count value as nothing but 0 here. Okay, and in the end I can simply return the counter, as I have discussed. So return the counter. Why we are using this while loop internally? Because it might happen that L might have to move again and again. So that is why I'm using this while loop. And in the counter I'm updating R minus L plus 1, as I have already discussed, for counting the sub arrays, guys. GG Yash went further. What does great going? Thanks a lot. Okay, so yeah, now what I will do is I'll compile this code and let's see if this does work or not. Guys, you can give me a +1 in the chat if everyone is clear. Time limit exceeded. Okay, yeah, I'm not moving my R also. So after that, I'll do R plus plus also. Yeah. At the very end, I'll also do a R plus plus because R will keep on moving. You can see we are getting the correct output 7. Now let's try and submit this code and see if this does get accepted or not get accepted. Uh, it doesn't. Okay, yeah. For larger test cases, I should take the product as long. To be very honest, yeah, I think I should take the product as long for the larger test cases. Correct, because it might happen that my product might exceed. Because if I multiply a lot of integers again and again, so the product overall might exceed the integer limit. So so that is why it is better to take the product in long. Thanks a lot for correcting me on this point, Sarjeet. So is this part clear to everyone, guys? For loop inside, maybe for loop inside. No, everything is working fine now, Tejas. So is it clear to everybody who is present here? If you are clear till now, right? So I'll just summarize this problem again. As I already told you that since we are using the two-pointer approach, sliding window approach, so that is why L will at most move from where? L will move from here to here. So L will move like this, and R will also move from left side to the right side. So the time complexity overall will be order of 2n, which is nothing but order of n only, a constant like linear time complexity. Space complexity, since we are not using any extra space, will be order of 1. If you and this problem was asked in, I think, in Goldman Sachs. It can be asked in other companies also. And if you have understood this problem clearly, so please hit the like button, guys, as an acknowledgement, and you can give me a +1 in the comments. And you can also you can write understood if you're clear, or if you're watching the recording. Okay, and make sure to share this video with your friends as well if you have understood everything till this point. Okay, so this is how we can solve this particular problem. And now I'll provide you the code. So guys, everyone understood, or is there something that is not clear to anybody? Just let me know, guys. Everything is clear to all of you? If you are clear, then you can hit the like button for the acknowledgement that all the things are clear. And now we have just come to the end of this history because the problem has been discussed. So now I will share this solution link as well. It will be the same in all the other languages also, because nothing much is different. No data structure or anything is used. We just keep on iterating. We multiply in the product, we multiply a of r, and left and right should not cross each other. If the product is greater equal to k, so we divide the left element from the product, and then we move our left forward, and we keep on doing this until the product is greater equal to k. So this is what we do here, right? If there is any question, I'm here for 30 seconds more, right? And also we have another problem of the day tomorrow, so I'll be discussing it tomorrow. If there are any questions, you can let me know in the chat. Also, make sure to check out the link that is given below, because Geek-O-Lympics is currently going on. So you can check out the offers and all the quizzes and everything that's going on for you. And this was it for today's session, guys. I hope that you like this discussion. And now I'll see you with another problem of the day tomorrow. So let's see how the problem will be. So I'll meet you tomorrow night. Thank you. And keep coding, guys. Make sure to subscribe the channel, right understood, after the video is over, and hit the like button. Thank you, everyone.